In this module, we will cover the adapter pattern, also known as a wrapper pattern. It's a very common one, used to let classes work together that couldn't before because of incompatible interfaces. I'm Kevin and I'll guide you through it. We'll start by describing the pattern, which will quickly lead us to two different variations, the class adapter and the object adapter. We will look into the pattern structure, and as a real-life example, we will use a travel agent scenario that needs to load cities from an external system. We'll continue with learning about use cases for this pattern and pattern consequences, which can be both positive or negative. We will end the module by looking into related patterns. Let's dive in with describing the object adapter pattern. The adapter pattern is a commonly used structural pattern from the well-known Gang of Four design patterns. Its intent is to convert the interface of a class into another interface the client expects. So, the adapter pattern lets classes work together that couldn't otherwise because of incompatible interfaces. There are two variations of this pattern, the first one being the object adapter pattern. So we'll cover that one first. Imagine that you need to integrate with an external system that exposes a city. You could, for example, be creating an application that needs to talk to an API that exposes these cities. Or you could just be talking to another application layer that works on a different model than the one you eventually need. For our use case, let's say we've got a city from external system class with a name, a nickname, and the amount of inhabitants as an integer. This city from external system class is exposed by an external system class, which contains one method, getCity, which returns our city from external system. But you cannot work with this city from external system class. Your system needs a city class, which consists of a full name property and an inhabitants property, which is a long or int64 instead of a regular int32. So now you somehow need to convert that city from external system into a city. Worded slightly differently, you need to adapt the external system. One way of doing that is via a wrapper. You can create a new class which adheres to a certain interface and which calls into the external system. After it gets the result of the getCity call at level of the external system, it converts it to a city object and returns it. That wrapper is what we would call a city adapter, and the contract or interface it must adhere to is what we could call our iCity adapter. The client then calls getCity on iCity adapter. Let's map this to the object adapter pattern structure. Our two classes, city from external system and city, are simple helper classes that helped us describe the pattern. They're not part of the pattern structure. Our external system, which contains the getCity method that returns a city from external system, that is what would be called an adaptee, the thing that needs to be adapted. This thus defines an existing interface that needs to be adapted, the specific request. So, in our diagram, we switch external system to adaptee. The iCity adapter interface is named the target. In other words, the thing we need to adapt the adaptee to. It defines the domain-specific interface that the client works with. So we switch iCity adapter to target. The client works with objects conforming to the target interface. The implementation of that target, the city adapter, is named the adapter, or, if you want, the wrapper that adapts the adaptee to the target. So we change the city adapter to adapter, and with that we've got our pattern structure. Let's implement this in an example. Time to implement the object adapter pattern. Seeing that in this module we're going to implement two different implementations from the adapter pattern, the object and the class adapter, I didn't create an implementation class in advance. So let's add one for the object adapter pattern. And let's name that object adapter implementation. That takes care of that. And let's get rid of what's in there. And now we can start. We'll start with the city from external system class. This is a simple class with 3 properties. We accept 3 matching fields in the constructor. Like that, we convey that this object must be created with these 3 field values. With that, we've got the helper class that our adaptee needs, so we can add that adaptee. The external system class. It exposes one method, getCity, which returns a new city from external system. As city name, I'll use Antwerp, which is where I live. The nickname for this city is Stad, and it has about 500,000 of inhabitants. Note that there's more cities named Antwerp in the world, but as far as I know, only one has nickname Stad. Then on to the city class. This is another helper class we need, and it looks a bit like the city from external system class. But instead of a name and a nickname, it only has one string property, a full name. The inhabitants property is of type long. That's an int64. The city from external systems inhabitants property is an int, which means int32. So these classes are alike, yet different. The next thing we do, now we've got this helper class, is create or define the target. We use an interface for this. An abstract class is also a possibility, but I prefer to use an interface in this case, as we don't need base implementation in this example. What the interface does is define a getCity method which returns a city instead of a city from external system. In other words, we've now got 2 incompatible systems. We can make them compatible by implementing this iCity adapter. And that's what we name the adapter. When we implement the iCity adapter interface, we see that we need to implement one method, getCity. But to make these compatible, we also want to store an external system property. In other words, we're going to be using composition to make these 2 different interfaces or systems compatible. For the demo, I'm newing it up ad hoc, but you can inject it if needed or otherwise ensure that the city adapter gets a hold of this. Again, as already mentioned, the design patterns should be seen as a template to start from. You can change the template if it fits your needs, as long as you stick to the intent of the pattern. And then we only need to implement the getCity method. We do that by calling into the external system and then adapting the result, which is a city from external system. In this method, we call into the external system. And then we adapt the result, which is a city from external system, to a city object. And that's what we return. With that, we've created our pattern. Now let's write some sample code to try it out. First, we new up our adapter. For that, we need to import the adapter namespace. And then we try to get a city from it. This should call into the external system and return a city object. To check whether that's really the case, we simply write out the full name and the inhabitants. Note that what should happen now is that the external system's getCity call, which would result in Antwerp being returned, will be transformed into a city object. So we should still see the string Antwerp being written out, including the nickname this time, Stad. Let's try that. And that is indeed the case. So far for our object adapter. Let's have a look at a variation of this pattern, the class adapter. The object adapter pattern we looked into works via object composition. What you see on screen now is the diagram we ended up with when describing the object adapter. The class adapter pattern is a variation which relies on multiple inheritance to adapt one interface to another. In our case, our city adapter would derive from the external system and from the target, assuming both are abstract base classes. There's only one little problem with this. C# is a language that prefers composition over inheritance, and it does not support multiple inheritance. We could do this in Java, but we cannot do this in C#. However, we can implement it with a slight variation. We can let our city adapter derive from the external system and implement the iCity adapter interface. Like that, we don't need multiple inheritance. We're implementing a base class, the external system, and we're adhering to an interface. And that combination is supported by C#. Let's have a look at the pattern structure. We're looking at the object adapter structure. With a slight change in which we state that the adapter implements the adaptee, we get the class pattern variation we can work with. The adapter no longer has to store an adaptee object to call into the specific request on the adaptee object. Because the adapter derives from the adaptee, it can now call into the specific request method directly from its parent class, the adaptee. Let's implement this. In this demo, we're going to implement the class adapter. For that, let's add a new class to our adapter project. We'll name it Class Adapter Implementation. I'm going to change the namespace to Class Adapter and copy over the code from our Object Adapter implementation, as it's about 90% the same code. There we go. Nothing new here. There's only one change we have to make, and that's at level of the city adapter class. We let it derive from the external system class and implement the iCity adapter. That means we need to implement getCity a little bit differently. We no longer store the external system as a property here, so we're no longer working with composition. Instead, we call getCity on the base class, the external system class. We can do that as we're deriving from it. And that should be it. Let's give this a try. To do so, we simply change the namespace we import. We're going to change it to class adapter, which means that now the classes from our class adapter implementation are used. And let's give that a try. And that indeed results in the exact same thing. Let's have a look at the use cases for this pattern. This pattern is useful when you want to use an existing class, but the interface does not match the one you need. Adapting a city class from one system to another one, for example. You can also use it when you want to create a reusable class, the adapter, that works with classes that don't have compatible interfaces. Lastly, use it when you need to use several existing subclasses, but you don't want to create additional subclasses for each of them. Yet, you still need to adapt their interface. In that case, you can use the object adapter pattern to adapt the interface of its parent class. Let's continue with the pattern consequences.